feel I've got a bit of the wrong spot today because you've all been fired up with how good the Internet of Things is and how much money you're going to make. And I'm now going to tell you about some of the problems you're going to hit in terms of the security. I'm not particularly trying to sell anything. I've been working in low-power wireless and sort of machine-to-machine for about 25 years. Been involved in writing parts of most of the specs for Bluetooth, Wi-Fi, Zigbee. I've chaired a number of groups in those. And also been involved in 3 startups where we've helped people put wireless into products. And I think the marketing strapline of the last one was we've actually put wireless into everything from sex toys to snowplows. You'd be amazed just what has wireless in these days. Last few years I've been working with smart energy, and we've been rolling out energy monitors to go into homes where we've got connected sensors that will pull back 1-second electricity data. There's currently deployed in about 150,000 homes in the UK. We've accumulated around about 3.5 trillion readings from that deployment. And we've got a team of data analysts who can literally look at that and detect individual appliances that are running, to the point that we even get an idea of the type of meal you're cooking from the way you're using your hob on your oven and have a good idea of who's in the shower, which gets scary and gets you into some of the privacy issues. But what I'd like to talk about, I'm going through that large-scale deployment, we learnt a lot about security. And also because I like taking things to pieces, I take a lot of products to pieces and have discovered that an awful lot of products have no security whatsoever. Today, when it's still sort of a hobbyist community, I'm using hobbyist in the nicest term, it doesn't matter too much. But as it starts to grow, it will. So what I want to do today is just talk through some of the problems, talk about the market and how it might affect the market, and try and give you some pointers of things to go and think about. Security is easiest if you do it at the beginning. It gets really difficult once you've designed your system, started to sell it, and then have to try and put it on afterwards. So, interesting one actually, if you're making devices, how many people here are involved in hardware? My God, I'm impressed. Good luck. If you're selling in Europe, you know the R&TTE directives. They're just putting or doing a revision of that, and there's now a line in it that says you actually have to make sure you have safeguards in your designs to promote or ensure the safety and privacy of any data that is sent off your sensor. I mean, that's rather interesting. I don't know how they're going to test it, but if you don't, there is a legal document out there you can get caught by. Because we know lots of things have been hacked. There's not been much malicious hacking going on, but just running through some of the news articles over the past year or so, there's a lovely one that was at one of the Australian conferences pointing out how you can hack into pacemakers. There's basically no security at all on those pacemakers. And if you go back, I mean, they're old devices. They've been around 10, 15 years, and people designing them didn't think about these problems. But you can easily get into them. Say with insulin pumps, which is a little more worrying because somebody, and this is a diabetic, who just thought, can I hack my insulin pump? And discovered that they can, and they can actually change the amount of insulin that gets injected, which does get a bit scary. There's a good murder story there if anybody's into script writing. Weir gates, and this is a lovely little one, some Zigbee-based Weir gates over in the States. And this was a simple one that somebody just tried a replay attack. And instead of having set up the design so that when you open the Weir gate, you say open to 75% or open to 80%, it had been set up so you just say no, incrementally open another 1%. So the replay attack just opened the gate and it flooded the valley underneath it. Things to think about when you design things. Set-top boxes, somebody hacked those a few weeks back, discovered that the security settings don't work on most of the ones out there. Fitness monitors have absolutely no security. If you look at most of the big name ones out there, everything is being transmitted in the clear. Smart meters have been hacked. We're told the next generation won't be. I personally don't believe that, having worked in the industry for the last few years and seen the quality of some of the firmware going in them. And the problem with all of these is that it will happen as devices get out there. In general, hackers only bother to hack something when there's lots of it, because hackers quite often tend to be in graduate departments of universities and like the publicity that goes out with a press release saying, we've just hacked this. We can remotely discover what TV program you're watching. That was one in Germany when somebody was looking at the electricity signal out of a little plug monitor. I won't name which one it was. And you can see the power consumption changing with the amount of light on the screen. And by comparing that against the television schedules, you could actually tell which program was on. It's amazing what people will do. Now, the question is whether some of this is hacking, whether some of this is just good practice. Nice one as well, sort of what you can look at. There's a number of games for mobile phones now that actually look at your accelerometer. So they can tell whether you're male or female, as the accelerometer reading is different if you have it in a trouser pocket or a handbag. And they will actually adjust the game settings according to that. There's lots and lots of stuff going on out there that you probably don't know about. So the consequences of that is people know a lot more about you than you might think. You may not worry about that, but some people may, and some of the nastier ones may actually make use of it. They also know where you aren't, which is the one that burglars really love. If they know you're not at home, it's a good time to break in. They know who you're with, which may not be very good for marital relations. And in some cases, we actually know what people are doing. A lot of these come into the privacy side, and privacy is going to hit us as the Internet of Things starts to grow. A lot of the early adopters, the quantified self amongst us, don't really care. We're doing it and we're being quite promiscuous with what we are. But when people that don't understand that get caught, you are going to start to see a reaction against it. There's a whole thing of identity fraud and pretending to be somebody else. And again, if you're starting to find out about devices, if you can go in and pretend to be somebody else, and a worrying number of servers sitting at the back ends, if you can get hold of somebody's ID, which often is just the serial number of their device, you can put your own data into that back-end system. Quite a lot of the home energy management systems I've played with, you can literally just make up what you think a serial number is, and it gets accepted by the server. No authentication whatsoever on them. And kids will start to play. It'll be the lovely one of turn your neighbour's lights out, then turn the school lights out, then turn the school heating off in the middle of winter so they don't need to go to school. Kids are bright, they'll do this. They'll hack into your electricity meters and you see your bills going up. Things will stop working around the home, or they'll start working differently, which is perhaps the more interesting one. But the end result of that is your business is likely to fail. And that's why it's important. If you don't get this right, then whatever you're trying to do can go horribly wrong. And even if the hackers aren't doing it maliciously, once the media picks up this is happening, they really are going to tear you to pieces. So it's important to think about it. If you're going out for investment and there have been hacking scandals, then the VCs will be asking you what you've done about security. So if you haven't thought it through, you're not going to get funding. This should be question time, actually. You've been sitting down all day listening to what the Internet of Things is. And the Internet of Things isn't one homogeneous thing. It's a whole set of different things, depending on what you think it is, what your business is. The classic one, the one that most of it is today, is a good old machine-to-machine one. This is Etsy's simple view of M2M. Being Etsy, the simple one is already complicated. But a lot of this is very much the vertical siloed applications where companies are recording data from a device and generally then just putting it in a store and throwing it away. Some of the brighter ones actually do something with it. But it's always amazed me the number of people you go in and you say, well, you're bringing all of this data back, what are you doing with it? And it's just, well, we just keep it so we can find out if something goes wrong afterwards. The whole thing about the Internet of Things is the value is in the data. Use the data. Go out and get some really good data scientists, as that's where the value is. If you're just pulling data back for the sake of it, you're probably wasting money. The one you may not be aware of, which is the new one, is something that's being called accessories. These are devices that are based on Bluetooth Smart, what you might know as Bluetooth Low Energy, or was previously Bluetooth Ultra Low Power, and Wi-Fi before that, keeps on changing its name. But it's now settled down. It's the new Bluetooth standard. It's not a variant of the old Bluetooth standard. It's actually a completely new ultra low power radio standard. And it's designed for just passing very small amounts of information between devices. But it's very much sort of asymmetric in that there's quite a lot of power you need in the controller device, but the one in the sensor is really, really low power. So people are designing things like keyboards with Bluetooth Smart that are running off an AA cell for about 18 years. They're designing sensors that run off coin cells that run for 5 years. And that's incorporated in most smartphones. Apple has it, Android phones have it, the iPads have it. There are now APIs out there for designers for writing apps. And if you go on to Kickstarter, Indiegogo, and look at some of the other startup companies, there's lots of interesting devices coming out that basically are sensors that interact with apps on the phone. Now, in the short term, that doesn't necessarily have an internet connection, but there's no reason why you can't put one on. And we're already seeing stuff coming out this year in that market, everything from toys, smart plugs. There's a wonderful motor for a paper plane that you just stick this on a paper plane and you can then control the plane from your phone by, I want one of those for Christmas. There's a massive amount of innovation. And over time, those are going to start to connect to the internet. I think this may be where we actually see the Internet of Things happen, from people making those devices and then going back.
It's good to mention that for this Bluetooth low energy or Bluetooth smart, there's also the IP standard for that. I think now almost finalized. So they're doing IPv6 over this low energy link. It's also in the process at least.
It's in the process.
Yeah.
It may stop at the gateway. It looks as if we're going to end up with the IPv6 down to the gateway and then coming down. But
some people believe in the IPv6 to this toy, basically.
Yeah, I personally do not believe in IP down to low power devices. But I come from a sort of hardware background where you're counting the energy of every bit of information. And if I put IPv6 down to a device, I've got half the battery life. And to me, that's not a good product choice. But you do have massive religious fervor on this. I mean, you almost have battles over what you do. So I think that's an important area that may be the one that grows into the Internet of Things. And then we have the smart home. It's a rather nice graphic from Parks as it's sort of color coding the various bits. We've got electric vehicles, if we ever really get electric vehicles. I tend to be cynical about electrical vehicles because every year all that happens is that the analysts just move the timescales by 12 months on their graph. But we have all of the other bits around the house. We've got security monitoring, access, a whole range of interesting stuff coming up on door controls where people are starting to look at door controls that are controlled by your mobile phone. New one up the other day from a company called August, which is quite a nice one, as that lets you program the lock to different friends' phones. So you can say, I'll let the builder in at this time. Massive amount of innovation going on in these devices. And then all of the other things from how much can we automate the home. I'm still unsure that when I get home each evening, I want to be a network manager for my house rather than just sitting down and turning the TV on. It's going to be interesting to see how smart our homes get, or whether the smart thing is that we keep them dumb. But basically, anything that can be connected will be connected. People are going to go out and do it. I think anybody that says that's the one that's really going to work and that's the one that won't is a fool, because we don't know. Something will spark people's imaginations and some will take off. But whatever it is you can monitor, people are out there already selling stuff that lets you monitor them. We keep on hearing the 50 billion Ericsson quote. I think that's the most inflated that any company's put out. The others are around about the 20 billion. But this was an interesting projection that I saw done from Cambridge Consultants. They're looking at those Ericsson numbers and saying, how do you get there? Breaking it down into the connectivity we know we'll get because we've got mobile phones and we'll get more mobile phones. We'll get a few IP phones on there, PCs, tablets and the like, sort of growing up, consumer electronics and the business-oriented machine to machine. And if you project those bits out, it goes up to about 25 billion, which is only half of it. And the real question is, if we're going to get to that 50 billion, that means a real change in the mindset of what we're doing. And that's where it's quite interesting when you look at some of those projections for the accessory market. Because the projections for those, as you're looking at the Bluetooth chips in these by 2020, will only be about 30 cents. Really suggest that that could be the point you'll get that other 25 billion devices. And that means there'll be 50 billion chances to hack something every second of every day. And that is really going to excite the hacking community. That is Christmas for them. So what do you need to do about it? Well, the first thing is understand the topology of this Internet of Things, because it isn't a simple one of saying, I got a device there and I've got a server there, and magically the data gets from those and you can make it secure. We've actually built it up of lots of different building blocks. So if you just take a simple one, like a home thermostat, simple one's going out today, that talks to your phone, and then somebody puts an application on the phone, so that talks to a back-end server. Server can do some clever calculations, remember what you like, send data back down to the phone, which goes to the thermostat. Now, the problem with that is if you're not in the home, you can't get the data out, so you go and buy a gateway and put that in. That sends the data back up, data goes back. As you've got two different routes, everything can talk to each other, and then, of course, you can look at taking data in, such as weather data from something else, or exporting the data to another service. Every one of those links typically is a separate link that has its own different form of security and authentication on it. And you need to think about how we put all of those together. If you go cellular, that helps a bit because you may lose some of those interdependencies. But today, that complexity is what is being rolled out and what is being put into most specs that are going forward for the Internet of Things. There's some other problems as well when you think about how this is going to be deployed, which is that you generally, in a consumer market, aren't going to buy all of those little parts of the chain from the same supplier. If you look at the smart thermostat, I'm not quite sure why the R's fallen down on the sensor, you'll probably get an installer to come in and put your smart thermostat in. If you're in the States and you're using Nest, that runs off low voltage, you might do it yourself. In Europe, where most of our systems run off mains voltage, you probably won't do it yourself. So somebody will come in that probably doesn't have much of a comms background and screw those things to the wall and connect it up and probably just plug the gateway into your existing router. And that will stay in your home if it works nicely, probably for 10 years or so. In the meantime, you've bought your own router and your own PC, and you'll probably change that router every couple of years, which means the passwords on it and the security settings will change every so often. And your PC will change at a different rate. Once you've got that in, that then talks up to whoever's providing the service. That today is the same person that probably is designing the hardware, although it's probably a different company that's been subcontracted out to do that. And they'll be looking at taking that data in. You may also be taking feeds in from your green button or something else so that you've got other energy data to go into it. There'll be manager for that database. And when I ask people to draw out what they do, that's generally what they draw. I've yet to come across anybody that actually draws in the two important bits, which is the device manager that actually manages all of your devices in the home, and a security manager that looks after everything to make sure that everything is secure and that link keys go where they should go. And again, you're looking at multiple different people with multiple different competences who you have to try and bring together to do this. Because almost everything we see out there today, those three different parts of the chain have been designed by three totally independent companies, and nobody sat down at day one and said, what's the overarching security model? Which generally means it's complicated, and it means that there are weaknesses within it. The other interesting weak link is if it's going to be usable, you need to have an application on the phone and the PC which is easy to use. And if it's easy to use, it's probably very, very easy to hack into. So there's my cartoon for the day. That's 3 out of 3. Some of the things you need to think about on doing this, there's not a lot of rocket science to security, but do sit down when you're designing a product or designing a service and think about everything from the sensor right through to the data import, if you're using open data interfaces, how you interface to everything else. And look and understand those separate elements of security. If you're doing a design with off-the-shelf components from different people, try and make sure that you've got consistency of that security. One really interesting one we've discovered in smart metering, it can sometimes be quite critical the order in which you actually install these products in the home, because you generally don't commission the end-to-end system all in one go. If you've got a number of different sensors, you'll probably connect those up to a gateway, and then the installer who's done that will give somebody a little key and say, phone up this service center and tell them you've got this installed and give them that number and everything will be set up. If somebody tries to preset that and do it the other way around, you can suddenly find you've got great gaping holes in security. We've had that in a couple of deployments we've seen. And the other one is don't rely on wireless security. And this is the really big one. I've come across so many companies who are installing typically M2M applications and asked them sort of, what's your security? What have you done? They said, oh, we don't need anything, we're using Zigbee. That's got AES in, that's secure. Wireless security is only across that wireless link. The second that data gets into your gateway, it's unencrypted. And there are vast numbers of products going out there that connect, well, in the States, in particular in Texas, where they've now opened up smart meters to allow people to buy gateways to pull data out. Almost all of those have no authentication whatsoever in the data being sent up. It's secure for the connection to the smart meter, that's under the Zigbee security, but after that there's absolutely nothing. And you can spoof most of the servers behind them really easily. So some practical considerations. Security model, security model, security model. If you're designing something, just think about how those different bits fit together. Because you don't do an end-to-end system, you generally don't have the flexibility to do that. You've got to think about the different bits of security. For your wireless link, implement security. So if you're using Zigbee, make sure you're using Zigbee Pro, otherwise the security is weak. Going back up, I would far rather see people using TLS than SSL because that's been cracked so many times. Please use salted hashes for passwords when you get to the back-end server. As we all know, very big companies have forgotten to do that. This is one of the other things. So many companies, they say, well, we're just doing a demo first. We won't bother with all of that. And then it's successful and it grows. And then when they're up to a couple of million customers, somebody hacks the whole thing. I won't mention names. There's too many of them. The only companies I've ever worked with that have done this well are credit card reader companies. I was involved in putting Bluetooth. Both chip and pin credit card readers use Bluetooth for their comms link. And I was involved in designing quite a lot of those. And the really nice thing about those is they don't trust any security. They overlay their own end-to-end security over everything. And it's really refreshing talking to them because they actually understand it. So few people do. If you can do end-to-end security, do it, but then you've got the issue of how you let the user in to do anything. The other interesting thing, but so much of this we talk about, we're going to have smart homes doing that, and it's all wonderful when we've got that model, but wireless links have a habit of breaking. And when the wireless link goes away, for whatever reason, because your GPRS system's down or because you've got interference, you really do want your heating or your air conditioning or whatever other service to go on working. So make sure you design stuff for autonomous operation. So if something fails or if there's a possible security issue, it goes on working. The customer will not like you if their equipment stops working. And here you've got the eternal dilemma that if we're going to sell 50 billion products, we've got to make them really easy to use so that everybody gets them and they just work out of the box. And it's quite difficult to do that with security. But there was a nice quote from Beecham recently that we've got to agree on this compromise. If we try to make everything absolutely secure, it's going to be unusable and the market won't grow. But equally, if we make it insecure and there are too many media scare stories, nobody's going to buy any. And that's a real shame because there is the market. So some practical points. Think about how you pair devices. One of the reasons that wireless specs are generally about 1,000 pages long is it's really, really difficult to make wireless as simple as a cable. I can specify a cable on a single page. It plugs into this, it plugs into that, it has so many cores. Trying to get those same combinations of security and bandwidth and knowing what you're plugging into is incredibly complicated. It's why we have lots of different wireless specs, because there's lots of trade-offs to get it to work. But that initial pairing of, I've got this device, now how do I know it's connecting to that rather than something else, because it's all these invisible bits going between it and I can't see, is really difficult. And one of the big security holes that can come out of that is if you've got, say, a wireless thermostat and it dies and you replace it, how do you put that replacement one in and ensure that you haven't broken the security anywhere in the chain? And that's a part of your security model, is think about how you would replace any individual item along that chain and make sure that that doesn't break it. Remember that a lot of these products aren't just going to go to geeks like us who will buy the next new flashy one next year. They'll go to people that say, well, my last thermostat lasted me 25 years, why shouldn't this one? They won't change it, They will expect it to keep on working. They will expect it to keep on being secure. But the dilemma on that, if you're having battery-powered devices, is the more security you put in, the more processing power you need to run those security algorithms, and your batteries won't last. And that's a real issue. Some of the really low power stuff is not as secure as we'd like it to be, because if we put elliptical Diffie-Hellman in, it's going to take half the battery life out when you first run it. It's working at the moment on devices that are running off tiny little silver cells, and just setting up security can be a real problem. And remember that a lot of these devices have no user interface, which is another interesting one for security. But the really important one I would say to everybody designing this sort of device, don't think that we're the target market. We're not. We've got a good idea of how it works. The customer just thinks it works out of the box with them knowing nothing. But if we get it right, it's going to be massive. That 50 billion devices is 5 times bigger than the mobile phone market was going to be. It's going to be the biggest single consumer product market out there. So it's worth spending a bit of time beforehand to try and do that. That's basically it for me. I've written a book on wireless if somebody wants to buy it, and I've got a blog with lots of articles on if you want to read them. But go and do it. It's fun.